Hello everyone. In this video we are going to look at some of the modifying tools or modification tools that are in Fusion 360 under design, and we are not going to go through all of them, but we're going to see a bunch of them. So here I have this simple block made, which is one extrude and two cut extrudes, and here I want to show you some of the tools. The first one is called press pull or Q, which basically modifies the geometry by a combination of extrude, offset, and fillet, as you can see, depending on which one of them is available. So let's say here, for instance, I want to make this hole on this object a little bit smaller. I want to pull the boundaries, right? So I click on this press pull and I select this boundary. And you see here, it is allowing me to pull this boundary, and look here, if I pull it, you see I can make the hole smaller or bigger. I can even go bigger and you see completely change the shape of the object, right? So you see here that I can make it bigger just like this by pulling it. Now you might say, what happens on this one? Well, this is clearly a surface, so if I want to pull it, that basically means making it thicker, you see, right? So here basically you're extruding. On the other case, you're doing an offset, right? So it depends on which one of them is available for that surface that you're picking, and then you can do this press pull, which is a relatively, I would say, fast and powerful command for modifications. The next command you can do is a fillet, which is rounding an edge so it's not sharp to cut your skin, or if it's an internal edge, you want to remove a stress concentration. So here you click on fillet and you pick an edge and you provide the fillet radius, and there we go. Here, that's filleted. Now you might say, what happens if instead of an edge you pick an entire surface? Could you do that, right? Can I pick an entire surface and provide 5 mil? Yes, now all of the edges on that surface will be what? Rounded to 5. And then you might say, can I change the fillet radius along the edge or on any path? The answer is yes. If you see here, it says radius constant, but if you want, you can make it change along the chord based on chord length or variable. So let's say I want to make it variable along this edge. And here, the start point, which is there, the radius, let's say, is 8. And the end point, let's say it is 4. Okay, and if 2 points are not enough and the simple linear relation that it makes, you want to make it more kind of variable, you click on this plus and add a point here, right? And now this new point, right, let's say I want to add it right there. That point, which is at a distance of 0.249. What does that mean? This is the fraction of the total length of the curve between the start point and the end point. So if you make it 0.25, it's exactly 1/4 of the distance. Over there, from 8, I want to actually go to 10. I want to go up, right? And then I want to add another point, maybe somewhere here in the middle. I want to go down to 2. And next, at let's say 3/4 of the length, 0.75, I want to change it to maybe 6, and finally go to 4. Right? So look here. You see how you're going up, going down, going up, and going down. So you can make it what? Completely variable if you like, right? And of course, you can see this crazy curvature because you are suddenly changing the fillet radius considerably. And the similar command is chamfer, which is basically cutting through a sharp edge. And here you click there, and then you can make it equal distance or 2 different distances or a distance and an angle. So let's say I want 2 distances, and the 2 distances are, let's say, for instance, here, one of them is, let's say, 8 mil, and the other one is like 5 mil. Okay, so you see that? There we go. and this is a chamfer, as you can see. Okay, let's move on. So the next command you can do is a scale, and a scale is similar to what you had in the sketches. So you scale the whole object with a specific scaling factor. So here I pick the scale, I pick this object, and you need the center of scaling, which could be the centroid or a specific point. Let's say here I pick this point, just for now. Point selected is right now that point. If you don't like it, let's see if I can change it to this point. There we go. And you can do a uniform scaling, or you can do non-uniform. Non-uniform means in different directions you can scale different values. So let's say, for instance, in the X direction, I want to scale it for 2. In the Y direction, I want to scale it for 1.5, and in the Z direction, maybe 1.2. Okay, and there we go. Right, so I could scale it. Okay, we move on. Now, the next two commands that I want to talk about are draft and shell. So draft is if you want to provide a draft angle, right, for any number of surfaces of an object, and shell is to make it basically just a shell, an object with a specific wall thickness, a uniform wall thickness. So let me show you that one as well here. So let's make another object in this case, and again, let's go with the simple box because you can easily explain everything on it. So we're gonna put it here, and there we go. So the command shell is very obvious, right? So here I say I want to shell this object. It says which body? I say this body. And then you can pick a face. That face will be removed, and then you can provide the thickness, which could be inside, outside, or in both. So let's say I want to keep a 4 mil wall thickness, and the face that you clicked on will be removed. As I said, you're gonna get the object as a shell. Okay, so that is the shell. Now let's suppress the shell. So you can right click on the shell, and you can basically suppress that feature if you want, or you can move this bar back, as I said, and you can suppress anything to the left of it. Or if you want a specific one, you can always right click and suppress it. So the other one is the draft angle. So here we go with draft, and it says, well, what is it that you want to draft? Let's say I want the faces to be drafted to be this face and this face, just 2 of them, not all 4 surfaces on the circumference of the object. And for pull direction, and here for the pull direction, let's pick this direction here, if it allows me to. Let's use one of these. So here, if I click on this face, the pull direction is going to be normal to that face. And here you can provide an angle, so let's say 10 degrees. And you see that those faces are now drafted at 10 degrees. If you reverse it now, you see the direction of the draft is backwards. Okay, and you can draft it in one side or 2 sides or symmetric if you want. And here it's just one-sided draft just for those 2 faces. If you look at the other 2 faces, you clearly see those 2 other faces are intact because we did not pick them. Okay, so this is about the draft angle. Now let me show you a few other things. One is if you want to move or copy an object, so you click on here, and I guess I mentioned it in one of my previous videos, but again, I'll do it one more time. The reason is I want to show you the logical operator. So here I bring this guy so that it has some intersection with the other one, and let's see if I can look from the top direction so I make a better decision about moving this. So here I bring it and put it somewhere that I can have intersection with this object. As you can see, it does have an intersection, and I okay that. So now that I moved it, I go ahead and I go with this command combine. And here you can combine two things or join them. You can cut one out of the other one, or you can get their intersection. So let's say I'm interested in the intersection of this body and that one. And if I okay that, this is the part that belongs to both of them. Or if I want to cut one out of the other one, I can also do that as well. So if I go back here, let's say I want to cut, and then here, so it is going to be cut what out of what. So the first one is the target body, the second one is the tool body, the one that is used to remove. So in this case, if I reselect them, let's say I want to remove this one out of this. So this is going to be my target body in that case. And then the tool is going to be this one, which is used for removal. And if I okay that, you see, that portion is gone through that drafted box, right? So the tool is the one that acts like a cut extrude, basically. Not extrude, like a cutting element. So this is the logical operators, which are very useful, and the application of them are, there are lots of applications. For instance, if you have a wing and a plate, you can do the intersection of wing and the plates, and you can get the ribs and spars. Let me show you that very fast here. But before that, let me show you another thing that might be interesting. So let me delete this and this one. So here I have this object, right? I have this body. One thing I can do, I right click on it and delete it. If you delete it, it goes away completely. Nothing will remain, okay? Like this, right? Done. It's not there anymore. Now, on the other hand, if I right click on this guy and remove it, not delete it, if I remove that, okay, that body is gone, right? But this guy here, which is that draft object, is still here in this bar. So although the object is gone from under bodies, but this one is still there. And if I right click here, right, can I get this guy back? So right now I can suppress it. I can convert it to DM features and so on. I can delete it. I can edit everything, right? Yeah. But can I get this guy back? And look at here. There is one thing right next to it. It says remove body. So that remove done, but it has added an operation here on the operation bar. If I right click on this remove body and get rid of this one or suppress it, okay, or let's delete it, do I have this guy back now? Look, yes I do. Look here, I have body 2 and body 2 is back, huh? Yeah, so you can see that this, let me bring this guy back. Here we go, body 2 is back. So remove is just getting it off of the bodies, not completely deleting it. Still, you have the icon for it and an extra icon for removing. And if you get rid of that remove part, you can get your object back. So that's the difference between delete and remove. Okay, now that you see that, I want you to see one better application of combine or intersection here. So here you can see that I made a very simple wing. Of course, the wing is way more complicated than that. And then I have this plate that completely cuts the wing. And if I do intersection of these two objects, this is what a spar is, a longitudinal structure along the span of the wing that is an internal structure, internal support for the wing, right? So here I can go and I can pick the combine and say this one and this one, and all I want is the intersection, and there we go. You get this object, which is the spar. And you might say, well, I could have probably just make this cross section and extrude it. Yes, but remember that first of all, the top portion and the bottom portion of it are not just simple lines. They are parts of splines here. That's one thing that you need to pay attention to. The other thing is many times the wing has a taper angle, okay? So the wing is not basically, it doesn't have the same cross section at the tip of it and the root of it, and most of the time it has a variable taper angle. So in this case, this extrusion, you see that there is no taper angle, but if you want, you can add a little bit taper angle to it. Let's see if I add like 3 degrees or something, and maybe negative 3 degrees. No, that was too much. Negative 2 degrees. And in this case, I assume I should go positive 2 degrees. So let's have that as the tip, this one as the root. Okay, so now you can clearly see that there is a taper angle, and to use intersection, you need to make sure this guy, you really want this guy to completely cut through the object. So for that reason, I have to go to this one, and I need to find the sketch of it, which is this, I assume, and edit that sketch, make it a little bit bigger. You see here, it is not big enough. So here we go. There we go. Now I have it. And now I click here, intersection, pick this one, and now you can see that you clearly have a taper angle as well as the cross section, which is not a rectangle. So you can get the spar. Or if you made the plate to go basically sideways, then you get the ribs. So here is an example of logical operators in internal structures for the wing. The next command I want to show you is a split. So you want to split an object with a plane or a surface. Here we do it with the plane, but later when I teach the surfaces, I also show you how to cut a body with a surface. So here I have this cone and I have this line using which I want to define a plane and then cut that cone with a plane. So here I need to create a plane passing through the line, right? So here you see there is a plane that passes through two edges. There is a plane that is along the path. There is a plane tangent to face at the point, and there is one through 3 points. So in this case, none of this will exactly give me what I wanted, right? Because I need at least 3 points, okay? And to get 3 points or 2 edges, I need to create another edge in this case, and I want to make sure that that edge basically forms a plane at angle. So if you could do a plane perpendicular to another plane, plane at angle, let's see. So I want a plane at angle with, and this is a line. Okay, and now the plane passes through the line. Now let's give it the tilt angle. If I do 90 degrees, there we go. This is exactly what I want, 90 degrees. So this option can give me what I wanted. And now that I have this plane, let's see if I can use it to cut. So let me just hide this sketch. And now I go here and say split body. And the body to split is this, and the splitting tool is this plane. And I OK that, and if I now hide this plane, right, let's see if I can go under construction and hide the plane, which I did. Now you clearly see your body is made into 2 bodies, as you can see here. Okay, and of course the intersection curve in this case is an ellipse. So this is a splitting the body, and now you can, let's say, get rid of one of them or delete them or suppress them, right? So I can go here and I can go to this body and simply delete it or remove it or anything. So let's say here, remove it, not delete it, remove it. So if you want it back, you can get it, and there we go. This is a split of that cone, okay? The last thing I want to show you is this tool called Align, which is a powerful tool and it can be used in assemblies as well. So here that I split this cone into 2 parts, I can move one of them now freely because now they are 2 separate objects. So I click on this guy and I move it out. Okay, so now you see it's a split. And now what? Now if I want to put them back, right, and I don't know exactly how much I moved it, I don't need to know that. What I need is go here and click on the Align tool, and then click on this surface, and then click on this surface. And there we go. Look, you're aligned. You can do the Fillet. If you do the Fillet, then they are aligned but anti-aligned. So their back surfaces are coplanar. And this is not what you want. And you can rotate them also in place. So look here. You can make this interesting object. Did you see that? I cut it. I made it like that. And now they are two separate objects. But guess what? I can pick them and I can combine them. Join. There we go. Now I have this single object. So I could go from this to this one. You see that? Powerful, huh? Very easily you can just split, you can align, you can rotate, and you can join back, and you can make something completely different. Now let me show you a few more things, although I went through the commands that I wanted to cover for this video, but let me show you a few other things. One of them is material. So far we have not talked about material, so you can go here and now you can apply some material to the object, which gives it a better rendering. So you go to Fusion Material Library. There is additive material library, nonlinear material, and so on. So right now let's just go there and maybe go to metals. And on the metals, let's pick something, right? So let's, for instance, one of my favorite things is bronze as well as copper. So let's say I want to apply bronze on this. So I grab bronze and just drag it and drop it on it. Just like that. Done. Here. The material is applied, and now the object is made of bronze along with the appearance of it. Now that I have a material, you might say, how much does it weigh? Or where's the centroid, right? Can we do those measurements? And they are not under inspect. This inspect is for measurements of length and angle, not inertia properties. So how do I get the inertia? Well, here, if you go to this body that you want to measure its inertia, you right click on it and go to properties. There we go. That's your total surface area, density, and then mass, and then volume, and then this is the bounding box, correct? That's the location of the center of mass. Can expand it a little bit to see better, and these are all the moments of inertia, the 9 numbers. So you can see the inertia properties right under right click and properties of the object. So I wanted to tell you that as well. Then also under display setting, of course, under visual style, you have shaded with hidden edges. So you can see the hidden edges if you want. And then of course you have shaded with visible edges only, like this. And you can do other styles too, like wireframe and so on. So you can do all of those. And also under environment, you can change the color of the background as well. So you have dark sky, you have gray room. Right now this is called photo booth, but let's say you want, for instance, river Rubicon or infinity pool, and you can change the color of the background if you want and modify the environment. Okay, and then there are effects that you can do. For instance, you can have the ground plane or get it off. You can add the shadow of the ground or get it off. Reflection, the object shadow, you can turn it off. Anti-aliasing, ambient occlusion, and then the object visibility. What is it that you want to see or not see, as well as the camera. Okay, right now is orthographic. You can make it into perspective and go back, and you can go into full screen mode, right? Then you can come back, exit that, and finally, let me show you. You can go here into multi-views. And now you should be able to see several views here, and each one of them that you want. Let's say you put this on the front, you click on this, you make it top, you click on this, you make it right, you click on this and you make it what? Isometric. And this is kind of what you see in drafting. Of course, that's not the goal here, but you can do a multi-view as well, right? And you can always go back to a single view. So these are some of the view options. Because we have seen the rest of them, I just wanted to show you these. This is for grid and snapping. right? So you can turn on and off, snap to the point, and make the grid be visible or not visible. And I showed you how to apply material. Then when it goes to appearance, then you can basically apply different appearances as well, right? And you can do it to bodies or you can do it to faces. For instance, I can apply a different appearance on this face than the other one is. So let's say faces, and then here for this one, I go under paint. I want to apply a different color, and I want to do a metallic color. And on this one, let's say I want to do a metallic, let's say red. Now, if you want to do that, you have to download it first. Okay. So here it should be downloaded. And once it doesn't have the download symbol, let's see if we grab it and drop it on this. And there we go. Here. Okay, so you can go to the paint and apply a different color on the object. We will look at the rest of these tools later. We'll look at the split face, replace face, offset face, and so on later. We're going to look at arrange and simplify, volumetric lattice, and manage material. This is for basically custom material. So in future videos, I'll cover those as well. And of course, using parameters and equations and parametric design, which is very, very critical. So hopefully this video was useful to you, and I'm going to see you in the next lecture. Thank you.